As I mentioned first semester, triangles are a big part of geometry. So we're going to continue looking at solving sides of triangles, and we're going to get into solving for angles of triangles using a couple of different things. The first thing we're going to look at is geometric mean. So we're going to identify the geometric mean and then use it to find sides of a triangle. Okay. So you guys have seen the word mean before in math. You probably have seen the word mean when you talked about mean, median, and mode. In other words, you guys did a plus b divided by n. So if you got two scores, an example of that would be if you had like a 90 and 100 on two tests, you divide it by 2 and your average would be a 95. That's what you guys have seen before. Geometric mean is a little bit different. Geometric mean is x over a equals b over x. Okay? Or the way of looking at this would be x squared equals a times b if you cross multiply. Okay? The geometric mean is that x. Geometric mean will always appear twice when you're setting up this proportion. We're going to focus on this way. Okay? X squared equals AB is not going to come in as handy when we work through some of these problems. So, just to be able to solve some of these proportions, let's look at a couple. So we want to find the geometric mean between the following numbers. Sometimes I'm actually going to give you the geometric mean, so we have to make sure we're careful with that. And then it says give exact answers. So find the geometric mean means we're going to say this is A, this is B, and we're going to call it x over 4 equals 5 over x. The geometric mean should always be diagonal. Cross multiply. We get x squared equals 20. Take your square root. We know we can't take the square root of 20, doesn't come out nicely, but we can do 4 times 5. 2 times 2, a pair of 2's. So x equals 2 comes out, 5 stays inside. The geometric mean would be 2 radical 5. Another thing I should mention about the geometric mean is it always has to be positive because it's applying to a shape, and we know sides of shapes have to be all positive numbers. It can't be 0 and it can't be negative because then it wouldn't be possible. So get another one. 1/4 and 9 find the geometric mean. So I'm going to say x over 1/4 equals 9 over x. Again, the geometric mean goes on the diagonal, cross multiply. X squared equals 1/4 times 9, or times 9 over 1 would be 9 over 4. Take your square root. So x would be take the square root of the top, which is 3. Take the square root of the bottom, which is 2. And again, we have a positive answer. Last one. Here's A, here's B. Yes, it looks a little bit different, but everything's still the same. So we have x over 3 equals x plus 6 over x. Again, that geometric mean is always diagonal. Cross multiply, gotta be a little careful here. We get x squared equals 3x plus 18. See an x squared, you see an x, you guys know the drill from here. X squared minus 3x minus 18 equals 0. Get them both to the left side. Box problem. There's no GCS, so we're going to go straight to the box. Okay. So we know it's going to be x minus 6, x plus 3 equals 0. Some of you are still forgetting this ZPP part right here. Set them both equal to 0 to figure out what would work. So x equals 6. There's one answer. X equals negative 3. There's another answer. And I just told you that the geometric mean always has to be positive. So if you used a negative 3, that would be a negative side length. We can't have that, so it's just 6. So that's how we solve geometric mean. Where we're actually going to use it is when we have two triangles inside a third triangle. So when an altitude is drawn from the right angle up here at B of a right triangle to the hypotenuse, or the bottom side, the three triangles formed are similar, meaning they're all the same shape, but one's bigger than the other, and then a third one's bigger than both those, but they all have the same side ratios. So what we have here is this triangle, we have this triangle, and then we have the entire triangle, and they're all similar to each other. So what you could do when we do these problems is basically set up three triangles and go, okay, this is triangle ADB. That's my yellow one. My blue triangle would then be over here and be triangle, let's see, DCB if you had to turn it. And then my fourth one, my red one that I drew, would look like this. And it would have to be, let's see, B is here. That's the right angle. These are all the right angles. And then C is up here. A is here. And then you'd go through and you'd mark all your sides and compare them and set up all your ratios. That's one way you can do it. And there might be a handful of you that do it like this. But we're actually going to look at a different way that makes it a little bit easier to solve some of these sides. So, first of all, a couple of the relationships that we're going to talk about are, first, the length of the altitude to the hypotenuse of a right triangle. So this right here, this length, is the geometric mean of the lengths of the two segments of the hypotenuse. So these two, A and C. In other words, what I'm saying is that y over A is equal to C over y. Because if we broke it up and we looked at these shapes up here, we would end up setting up a proportion that would be the same proportion as what we have right here. It's just a lot quicker. So again, that middle altitude right there is the geometric mean of the two sides below it. Okay, that's one thing we will look at. So y over A equals C over y. The other one we'll look at is that the length of a leg of a right triangle, so the length over here, or the length over here, is the geometric mean of the legs of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So again, kind of wordy, okay, but I'm going to explain exactly what that means. So for x, for example, that would be x over A, so this side here, equals B over x. So x over the short side, AD, that short length there, which is, we just have it labeled as A, so x over A equals B over x. It's the geometric mean. We're also going to use it here on this side, and it's going to be the same kind of thing, except for it's going to be Z over C equals, and then it's going to be B over Z. Okay. A little confusing, little wordy. I'm going to help you guys make it a lot easier. So again, if you wanted to, you could redraw all three of these shapes, all three of these triangles, and go from there and set up ratios. Or you can do what we're about to do. And that's the mean mountain. That's what I like to call it. Okay? This is an easy way of remembering this. Anytime you get one of these problems, you start at the corner and make sure that the hypotenuse is the one face down. So we're going to have to do it a little bit differently in number 2. You start at a corner, you draw up to the first geometric mean. Then you come down to the side. You go up to the second geometric mean. You come down to the next side. You go up to the third geometric mean. You come down to the side. And you'll notice it kind of creates a mountain. And the geometric means are always at the tops of the mountains. Always, always, always at the tops of the mountain. Okay? So, for example, what we would have here is x. I'm just going to give you one example. X over A equals B over x. Okay, so x is the geometric mean of A and B. Okay, and that's the way we'll look at it. And I'll help you guys with a few of these as we go on. So let's look at some with some actual numbers in here so that we can look at it. Now in number 2, you're actually going to have to kind of turn your paper to draw your mean mountain. So I'm actually turning my computer right now, and I'm going to start here, draw up to the side, go down. Draw up to the side, go down. So you're always going to sides and you're finishing at the corners there. Here's my mean. Okay? And now we can go ahead and answer all these questions. Notice how A, B, and C are all at the tops of the mountains. They're all the geometric means. Okay, so those are the numbers that you're going to write twice in your proportion. We're actually not going to set up proportions. We're just going to look at what these would be. But A is the geometric mean of 3, the side right below it, and the entire side, which is 3 plus 5 or 8. Okay. B is the geometric mean of the two that it's connecting to. So you go down both sides of the mountain. So B is the geometric mean of 3 and 5. That's the only one that you don't add things together. So you go down to the bottom left of B's mountain, you go to the bottom right, and you take the 2. So 3 and 5. C is the geometric mean of 5. So going straight down means mountain to the left, you end up at that 5 there. And then the entire length you have to compare to again is 8. So that's where it gets a little bit tricky, because what people like to do for C is do 5 and 3. That's not right. That's only for that middle one where you have B. Okay? So that's how those need to be set up. Let's look at a couple more of these and then actually solve some so you guys can kind of see where this is all coming from. So use the diagram to fill in the following. X is the geometric mean. So again, all of these at the top of the mountains are the geometric mean. So let's go ahead and draw our mean mountain. Go only to side lengths. Don't go to angles until you get to the end. That's where you finish. I like to draw my little snow caps there. So X is the geometric mean of, you go down X's mountain to 3, and then to cover the entire thing it would be 3 plus 9 or 12. Therefore, X over 3 equals 12 over X. Cross multiply, X squared equals 36. Here we go, we got an easy one. X equals plus or minus 6. We would just say the positive 6 though. Okay? So that would be the length of X. Different one. Z is the geometric mean of, this is the easy one, this is the middle one. Geometric mean of 3 and 9. Go down to the left, down to the right, 3 and 9. Therefore, Z over 3 equals 9 over Z. Cross multiply. Z squared equals 27. Take the square root. Z, oops, we can't take the square root of that. 3 times 9. A couple of 3's come out. So Z is the square root of 3 times that equal 3. There's your answer there. And then one more for Y. So Y is the geometric mean of 9 and 12. So 9 and 12, set it up, and we're going to have Y over 9 equals 12 over Y. Cross multiply, Y squared equals 9 times 12 comes out to be 108, I believe. Yes, it is. Take our square root, and let's break this up by, and if we just did 12 times 9, you can break it up into a 12 and a 9 if you want. Or you could go, let's see, let's divide by 4 maybe. Yeah, that works. 4 times 27. Pair of 2's. 3 and a 9. Pair of 3's, pair of 2's. 1, 3 stays inside. So a 2 comes out, and a 3 comes out. So that's 6. A 3 stays inside. And there's your answer. Okay, so just getting some practice with actually solving them. So now we could go back and say what all those lengths were. It'd be the same idea if you broke all the triangles up. This is a much quicker, easier way to do it. I believe I have one more on here. Okay. Solve for X, Y, and Z. Round answers to the nearest hundredth. Okay, so in this case, I actually told you to go ahead and round answers to the nearest hundredth. And what we're going to do here is start at the corner, go up, down, up, down, up, downs. You football players know what I'm talking about. Or maybe other sports do, I guess. So we have our tops of our mountains. Solve for X, Y, and Z. Alright. Now notice we have two variables here and we actually have a known here. So what that means is one of our geometric means we already know. We're going to hold on to that one for a second and think about where we have to start. So if I looked at Z, I would have to do Z over X equals X plus 7, because this whole side is going to be X plus 7, over Z. Now you guys can see what the issue would be there. So we can't start at Z, so let's try starting at Y. So if we do Y, that'd be Y over X equals, and we'd have X, oops, I'm sorry, Y over X equals 7, going down the other side, over Y. That doesn't work because you have X's and Y's. So we have to be starting at that far right, where we have 10 as our geometric mean. So this is where 10 is actually going to appear twice in our proportion. So we're going to have 10 over something equals something over 10. That might be a good way to set it up because you know that's your geometric mean. So go down 10's mountain to 7, and then you have to go across the entire mountain, which is X plus 7. Now you only have one variable, you're good to go. Cross multiply, so we get 100 equals 7x plus 49. And go from there. So we get 51 equals 7x. That's not going to come out nicely, so let's go ahead and do 51 divided by 7. We get about, what did I say, nearest 100, so 7.285, so we'll call it 7.29. We would round up to there, so there's what x is. Okay, so we have that taken care of. And now we actually have to use that answer to find the next two. So we know now that I'm going to get rid of this x and call that 7.29. And down here, 7 plus 7.29, this is actually 14.29. So now I'm going to use it to find the other two. Not going to be the greatest looking numbers, but again, we're just getting practice with finding out how to solve for these. So now we can go to anywhere we want. So I'll go to y next, and I'll say that y is the geometric mean of something. So it's the geometric mean of 7.29 and 7. Go down both sides of y. So we have y squared equals 7 times 7.29. That's 51.03. Take the square root of that. We get y equals 7.14. So there's y. We don't need to plug y back in because it's not necessary. We always need to know these bottom sides, but we don't need y there. And the last one, let's go ahead and set up z. So z over something equals something over z. That's our geometric mean. So go down z's mountain to 7.29. Then go across the entire range of mountains, so 14.29. And we have z squared equals, let's see, that's going to be 7.29 times 14.29. 104.17. Take the square root. And z is equal to 10.20657, blah, blah, blah. So that's 10.21. And there are our geometric means. Two geometric means. I should really have approximated these like I did on the first one, so that I show them rounding. Okay, so again, geometric means are always at the tops of the mountains. For the outside ones, you have to go down directly to it. So like for 10, you go down to 7. Then for the next part, you go down 7, and then the entire bottom side, which is 14.29 in this case. Okay, so that's geometric mean. Make sure you're able to use it. Go back and watch any of these examples if you need to again, and I will see you guys tomorrow.